Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I am Gholiyahtul Fitri Harahap with student ID 241093016. I am from group 12A for the Industrial Statistics course. So today, I will explain about single variance estimation and hypothesis testing. But before that, we need to know what is single variance. Single variance is a method in inferential statistics used to estimate and test the variance of a population based on sample data. It helps us understand the spread of our data and determine if the population variance matches a specific hypothesis value. Now, let's look at the data we use to study. This data set represents product patterns in 2025. Here are some of the value, like 4.5, 4.5, 4.5, and so on until it's 86 observation. We collect these ratings is to analyze how consistent or variable the product performance is. Now let's move to the our objective. Our objective is how to estimate the variance of product ratings and conduct a hypothesis test on the variance of product ratings in 2025, assuming a hypothesis variance is 0.1. First, let's look at the parameters we had calculated in Excel. First, we had the sample size that is equal to 86, mean that is equal to 4.77. The confidence level that is equal to 95%, standard deviation that is equal to 0.1418, and the variance that is equal to 0.0201, significance level equal to 0.05, alpha over 2 is equal to 0.025, degree of freedom is equal to 85, chi-square table apple is equal to 112.3934, and the chi-square table lower is equal to 61.388, and the hypothesis variance is equal to 0.1. Now let's move to the interval estimate. To calculate this, we must calculate it with this formula. After we calculated this, we will have a result that is 0.0152 is less than sigma square is less than 0.02. This means that the true population variance is estimated to lie between these two values with 95% confidence. Now let's move to the hypothesis testing. Our hypotheses are H naught is sigma square equals 0.1, and H1 is sigma square is greater than or equal to 0.1. Now we need to calculate the chi-square calculated with this formula, which is the chi-square calculated is equal to 17.0849. Now let's move to the critical region. That if it would be rejected if the H naught if chi-square calculated is greater than chi-square alpha over b. It would be accept if the H naught if chi-square calculated is less than or equal to chi-square alpha over 2, since our chi-square calculated is less than the table value, so the H naught is accept. For the final conclusion, there is not enough confidence that the variance of product ratings in 2025 is different from the hypothesis of variance of 0.1 at a 95% confidence level. Now let's look at the chi-square distribution graph. We can see that distribution for 85 degrees of freedom. The shaded blue area on the right represent the rejection region. That is starting from our critical value that is uh, that is 112.3934, and our calculated chi-square value which is uh 17.0, right? 0849. Our calculated chi-square value falls far to the left of the total region in the white area. This is visually confirms that our decision to accept the null hypothesis is correct. And that's all from me. Thank you for watching.